Hey everyone, I'll take a look at the first two questions in section 2.7, numbers 1 and 2. In number 1, we're given this graph of a function and we're asked to find the horizontal asymptotes for this function. This relates to limits at infinity, right? This function actually has two horizontal asymptotes. And as x goes to infinity, in other words, as x gets bigger and bigger, 20, 30, 40, 50, 100, a million, a billion, what does the value of the function appear to be approaching? Well, it looks like it's getting closer and closer to a value of 3, right? A height of 3. It's getting closer and closer to 3. We would say that 3 is a horizontal asymptote for this function. On the other hand, as x gets closer and closer to negative infinity, gets larger through the negative values, negative 10, 20, negative 30, negative 50, negative 100, negative 1,000, etc. The graph appears to be from the graph, the figure shown, the function f, or whatever this function is, I guess we don't have a name, is getting closer and closer to what? A height of about -1, right? And so those are the limits at infinity. At positive infinity, right, the function's approaching 3. So x goes to negative infinity, the function's approaching -1. And those indeed relate to the horizontal asymptote. So when they say define the equation of the upper asymptote, by upper they mean the asymptote at a height of y equal 3. In fact, equation means you have to have an equal sign in there. So asymptotes are indeed horizontal lines, so their equations are always y equal some number. So the other upper asymptote would be y equal 3. The lower asymptote would be y equal -1. Okay, so that's good on that one, hopefully. And let's look at the next question. Here we have multiple choice. We have 4 different graphs to choose from. Well, select all possible graphs for this. We have 2 limits. The limit as x goes to infinity is 0, and x goes to negative infinity is 2. Okay, so for this function, as x gets larger and larger, we're clearly approaching very rapidly y equals 0. So the limit as x goes to infinity is indeed 0. But as we go to negative infinity, we're also approaching 0, not 2. So this one would not be consistent with these 2 limits. This one, as x goes to infinity, right, it appears to be getting closer and closer to the x-axis, which would be y equals 0. So we do have that first limit. And as x goes to negative infinity, here we're getting closer and closer to this dashed line, which is at a height of 2, y equal 2. So this one here certainly satisfies those 2 limits. This one here, as x goes to infinity, we're getting closer and closer to the x-axis. Right, so our limit is 0. And then as x gets closer to negative infinity, we're following this path of the function and it's getting closer and closer. It looks like a height of 2. There's no dashed line here like we had in this case, but it looks like we're approaching a height of 2 there as well. Here, as x goes to infinity, it looks like we're getting closer and closer to this dashed line, which is again a height of 2. So that would not be this limit. This limit would not be 0, but would be 2. So we're not going to select that one. And then this one's kind of hard to see. You might want to zoom in your browser to look at it. But as x goes to infinity, it looks like we're approaching 0 from below, right? From below, getting closer to the x-axis. But as x goes to negative infinity, it looks like we're approaching 0 as well, and not 2. And so I would not select this one because this second limit is not true. So let's see if I've correctly chosen on this. Yay. Okay, so I hope this is helpful for these 2 problems. If you have any questions about them, please let me know.